Welcome everyone to AURI Connect's Webinar Wednesday, part of AURI Connect's monthly online series featuring updates on the work that AURI is doing to foster long-term economic benefit for Minnesota through value-added agricultural products. I'm Dan Scogan, the AURI Director of Government and Industry Relations, and your host on Webinar Wednesdays. The AURI Connects program is hosted by the Agricultural Utilization Research Institute of Minnesota. This program aims to actively engage all participants in the food and ag industry to improve competitiveness of producers, businesses, and entrepreneurs through ongoing, purposeful connection of resources and partners along the value chain, and increase knowledge of opportunities, technologies, and trends. Remember that this event is being recorded and archived and can be found at auri.org. Remember that you will be muted during our presentations, but you can send us your written questions through the Q&A portal on your screen. Today, we will be learning about efforts to identify value-added uses for Okara from Minnesota's only tofu manufacturer, Min Tofu, in research funded by the Minnesota Soybean Research and Promotion Council. Our guests will describe the research focused on fermentation to improve both the hedonic and nutritional profiles of Okaras as a baking ingredient in traditional and sourdough breads. Leading our panel today will be Jason Robinson. Jason is the Business Development Director of Food at AURI. So with that, Jason, I'll call on you to set the context and introduce this panel for today's Webinar Wednesday.
Great, thanks so much, Dan. Appreciate that intro. As Dan mentioned, this research was really focused on a challenge around finding novel, value-added opportunities for tofu okara. Okara is a byproduct, also known as soy pulp, from tofu manufacturing. We'll dig into that a little bit more as time goes on, but let me start by just repeating some of our primary approaches to identifying new opportunities and novel value-added approaches for okara. One, we explored fermentation via a traditional approach using a tempeh culture. Then we took a look at using that fermented okara compared to unfermented okara as a flour, as a traditional bread ingredient, as well as a sourdough bread ingredient, with the idea that okara could be used to improve the nutrition profile and potentially by adding protein, as okara does contain 26% protein. And then finally, because our goal was to identify value-added opportunities and not just food opportunities for okara, we did explore as an organization, we did explore opportunities for okara in non-human food applications, such as for animal feed, as a compost, or as an input to a waste-to-energy system. I'd be remiss if I did not introduce our collaborative partners on this. AURI partnered with the Northern Crops Institute, also known as NCI, located in Fargo, North Dakota, with Dr. Minwei Xu, who is formerly a PhD food scientist at NCI, but is now an assistant professor at North Dakota State University, who focused on the fermentation science. We also work with Rachel Carlson at NCI, who's a food scientist that focused on the bread analysis and evaluation for traditional bread. Moving on, Brian LaPlante from Back When Foods, a frequent AURI collaborator, worked with us to conduct the sourdough bread analysis using okara flour. And finally, while Min Tofu is not speaking today, we do want to thank them for their partnership in this project, particularly as they provided all the okara and background in tofu processing that we needed in order to effectively understand what was going on. And as Dan already mentioned, this research was made possible through funding by the Minnesota Soy Research and Promotion Council. So we want to thank them as well. But let's move on into the meat of our conversation today. Tofu as a product was first mentioned in the written record over 1,000 years ago in the Qingyi Lu, a Chinese document that was written somewhere in 890 to 960 AD. Ever since we've heard about tofu as a food ingredient, we've also experienced okara the byproduct from tofu manufacturing. Tofu is manufactured in a process whereby soybeans are soaked, ground, and then the resultant mash and soy milk are separated via a filtration process. Prior to filtration, that mass of soybean mash and liquid may or may not be cooked. Post-filtration, the streams are separated into the Okara, which is very wet and will deliver approximately 1.1 kilograms of Okara per kilogram of soybeans used, and the soy milk stream. The soy milk is then coagulated, pressed to firmness for the tofu, packaged, pasteurized, and cooled. So coming out of this process, we have this Okara byproduct stream that is high in protein, oil, and complex carbohydrates such as hemicellulose, pectin, and cellulose. So since the time of its earliest production, the great majority of all Okara has been used as a livestock feed, fertilizer, or as food for the poorer classes, according to the written record. Of course, today, we recognize the value of this byproduct stream and actively search for opportunities. However, because of the high water content of fresh Okara, it's a perfect environment for microorganism growth, and thus putrefies quite rapidly, spoils rapidly, typically resulting in landfill application unless the manufacturing location happens to be close to a feedlot or a farm where the material can be used for animal feed. This project really focused on fermentation of fresh Okara. You're using its high moisture content to metabolize the low value oils, protein, and carbohydrates by specific microorganisms into higher nutritional value compounds. At a top level, our research goals and objectives really focused in 3 different areas. The first, in goal 1, was to focus on the processing, evaluating, and comparing of fresh Okara as both fermented and unfermented flours for later use as a baking ingredient. In goal 2, we evaluated the impact of incorporating both fermented and unfermented flour as an ingredient in traditional bread. And then we also compared to Okara's performance as a type 1 sourdough bread ingredient. Brian LaPlante will get into a little bit more detail about that. And then finally, in goal 3, we evaluated other value-added uses of Min Tofu's Okara product stream in an effort really to keep it out of the landfill. So with that, let's move on and talk a little bit about fermentation of Okara and Okara flour. And I'll pass it along to Dr. Minwei Xu. Minwei, on to you.
Thank you, Jason. So, as presented by Jason, Okara is one of the major byproducts of soy milk and tofu. There are 3 main challenges to make Okara into food. The first one is the composition of Okara is carbohydrate, protein, and oil, and most of these nutrients are insoluble in water, which resulted in a lower nutritional profile. On the other hand, the texture of raw Okra is brittle and bran-like, and there is always some beany flavor included in the Okra. So fermentation is a safety and economical method that has been applied to cereal and legumes. So take the tempeh as an example. The Rhizopus oligosporus could convert soybean into tempeh with an increased nutritional and sensory properties. So this project would increase the nutritional value of Okra using the Rhizopus to increase the solubility of nutrients and antioxidant activities of Okra. So in addition, the fermentation could also improve the texture of Okra with a soft microbial hyphae. So moreover, the metabolites of Rhizopus include short-chain alcohols, aldehydes, and acids, which could be the flavor compounds cover the beany flavor. So next. Thank you. So the objectives of my section is to develop fermentation process for Okra and evaluate the nutritional value of okra. So the fermentation process we used is tempeh formula developed by NCI. So briefly, we added 3 grams of commercial rhizopus per kilogram okra, and then we sprinkle the vinegar on the okra to inhibit some of the bacteria. Then we mixed slurries for about 3 minutes and put them in the oven at 30 degrees Celsius, 80% humidity for about 48 hours. Then we harvested the fermented okra. Next. So we also evaluated the nutritional value of fermented okra, such as isoflavones, vitamin B12, dietary fiber, antioxidant activity, and gamma-aminobutyric acid. These are key nutrients that would do a great health benefit for human beings. We outsourced these items to Eurofin and the Medallion Lab. These are 2 professional testing companies. Next. So now let's turn to the results of our experiment. This slide shows how the mold grows during our fermentation. Figure A shows the fermented okra we developed for the pilot scale okra at NCI. So when we ferment okra from the industry, we found the final product is different with that we previously produced at NCI. So the fermented okra becomes dark, and the fermentation time extended from 2 days to 7 days. Then we carefully compared the difference of okra between the industry and the pilot scale. There are mainly 2 differences. The first, okra needed to be delivered for 1 to 2 days from Tofu company. It is spoiled when it arrived at NCI. While NCI can produce pilot scale okra by ourselves so that we don't need a delivery. Second, the moisture content of okra from industry is 10% larger than pilot scale okra. So then we designed an experiment to prove the effect of inoculating time and the moisture content of okra on the okra quality. As shown in figure B and figure C, the okra moisture is 70% and 80% respectively. Higher moisture would result in a delayed fermentation time, as well as darker color. The reason is that the rhizopus is aerobe, and they need a lot of oxygen for growth. The higher moisture content would prevent the oxygen enter into the inner layer of okra. And the figure D and the figure E showed the delayed inoculation time. And it would result in the growth of constitutive microbes. When delayed inoculation for 24 hours, as shown in figure D, the fermented okra become dark. And when delayed inoculation for 48 hours, as shown in figure E, the yellow colonies grows, which is not considered as safe. So high moisture and delayed inoculation time would result in a contamination by other microbes. Next. So based on this research, we changed our transportation. We deliver the okra by ourselves from Tofu company with only half days, and we collected the drier okra rather than the wetter one. So then we inoculated rhizopus immediately once it arrived. Finally, we got the white product as shown in the left picture. However, it is still not stable. Some of the okra are still dark. Anyway, we only collect the fermented okra with the white color in the following experiments. Next. So based on the experiments we performed, the okra fermentation is deeply affected by the competitive microbes originally in the okra. Therefore, it would be great if we can pasteurize the okra before the fermentation process. We can either cooking and drying the okra before the fermentation, or cooking the soy milk before we get okra, as shown in this picture. Anyway, the fermentation process of okra has a great potential to be improved. I just mentioned about it. Next. Now, let's turn to the nutritional value of fermented okra. The potential health benefits of isoflavones may include protection against the age-related diseases like the cardiovascular disease and the hormone-dependent cancer. So, as shown in the right picture, the form of isoflavone can be classified as glycosides and aglycones, marked as A and B respectively. Humans absorb isoflavone aglycones, which is B, faster than their glucosides, which is A. Therefore, higher aglycones are better to our health benefits. Now let's turn to the left picture. From this picture, we can say that fermented okra has a higher aglycones content than raw okra, while has a lower glycosides content than the raw okra. We can infer that the fermentation transfers glycosides into aglycones. So, and as to the increased total isoflavone content, it must from the rhizopus, because rhizopus can biosynthesize isoflavones from the okra. Next. So, and the next one is vitamin B12. So vitamin B12 is an essential vitamin that your body needs but cannot produce. Yeah, thank you. It can protect your vision, nerves, improve your memory, and etc. So fermentation of okra increased by at least 10 times the content of vitamin B12, according to the National Institute of Health. The recommended daily intake of vitamin B12 for an adult is 2.4 micrograms. It means that the fermented soy okra could contribute a meaningful amount of vitamin B12 to the human diet. Next. So the antioxidant activity is the next one. So it is a scale that evaluates the free radical scavenging capability of food. High antioxidant activity would support a healthy immune system. So the fermentation with rhizopus increased the antioxidant activity of okra by 18%. In comparison with published values, the absolute values of antioxidant activity for both fermented and unfermented okra fall within the range of data reported for red wine and ready-to-eat cereals. So it's also considered as a good one. So next, the dietary fiber can be classified into soluble fiber and insoluble fiber. Both are considered good to your health. The soluble fiber can slow your digestion and deliver antioxidants to your colon, which could prevent the colon cancer and be good to the intestinal flora. The insoluble fiber can speed up the movement and the processing of waste, helping prevent the intestinal blockage. So interestingly, in this experiment, the insoluble fiber decreased while the soluble fiber increased during okra fermentation. This is inconsistent with our previous research, because normally the enzymes created by the rhizopus, they can hydrolyze the insoluble fiber and into the soluble one. But anyway, it is not the purpose of this research. Either the soluble or insoluble fiber has its own health beneficial. Next. So to make a conclusion for my part, we successfully developed the process for fermenting the okra by rhizopus. The nutritional value has been improved after fermentation regarding to the isoflavone, vitamin B12, and antioxidant activity. However, the fermentation process still has potential to be improved. The cooking and the drying process is suggested to be added for a stable fermentation product of okra. And the nutritional value of fermented okra is also supposed to be improved by the optimized process. So much for this. So next one. Thank you. So now I would like to yield to Rachel. She will introduce the okra bread assessment. Let's welcome.
Thank you, Minwei. So next, I will talk about what we did with the Okara flour after Minwei produced it and fermented it. So I was tasked with setting up a baking study. So we are looking at how the Okara, unfermented Okara flour and the fermented Okara flour affect the final bread quality. And so the first part of the study we'll talk about is the unfermented Okara flour. So what we did is I baked a control, which was 100% whole wheat pan bread. And then we added or replaced the whole wheat flour with 5% Okara flour, 10% Okara flour, and 15% Okara flour. And so these percentages are on a baker's percent. So based on 100% flour weight, and everything else is adjusted to be a percentage of the flour weight. So when we did 5% Okara flour, it was 95% whole wheat flour, and then 5% was replaced with Okara flour, and so on to the 10 and 15% levels. I did a pretty standard whole wheat formula, nothing really, it's pretty basic formula, good for testing ingredients and variability amongst treatments. We did a no time dough pan bread. And so a no time dough is a very quick process, minimal fermentation in the baking process. Basically, you go from mixer to mix, divide, shape and mold, put it in the pan, proof it, and bake it. So within 2 to 3 hours, you can have a loaf of bread. So that's the process that we did in this study. So for the 5, 10, and 15%, in the mixing side, we did see some differences in the water absorption. So before I baked, I did farinographs for all of these blends, and we saw that there is a slight increase of just under 4% when you add Okara flour. So we saw a 4% increase in water from the control to the 5, 10, and 15% unfermented Okara flours. There wasn't a difference between the 5 and the 15% in water, same amount of water. Mixing times were all roughly the same, within a half minute to a minute. So no real difference. The only thing that I noticed in the mixing side is, we're determining mixing times based on feeling the dough and making sure and looking at the gluten development. In the 10 and 15% levels, we really didn't see a good gluten strength, which is to be expected when you're replacing the flour that has the gluten with Okara, which doesn't have gluten. So essentially you're adding kind of a dead weight into the dough system. So the whole wheat flour has to make up for that in the gluten strength. But at the 10 and 15%, the bread really broke apart, or the dough really broke apart really easily. There was not a whole lot of strength and not a whole lot of extensibility. So then when we got to the proofing point, especially on the Okara, unfermented Okara side, we proof to height. So we have a template that we hold over the pan of the bread, and once the dough has risen to the certain template height, we bake it. The 10 and the 15% never reached height. They proofed for 3 hours and just didn't have the strength to make it. So that's why you see in the picture, you can see much smaller loaves compared to the control on the 5%. So on the final dough, or on the bread side, we looked at texture analysis of the crumb as well as the loaf volume of the bread. And as we increased Okara flour in the dough system, we decreased loaf volume. And as we increased Okara flour, we saw an increase in firmness in the bread crust. So, which makes sense. The smaller the loaf, the more dense the crumb, the more firm the crumb is going to be. So my recommendation here would be no more than 5% addition of Okara flour, unfermented Okara flour in the dough side. Next I'll talk about the fermented Okara flour. We did essentially the same study, same formula, same treatment levels at 5, 10, and 15%, but instead of unfermented, we used fermented Okara flour. And we saw many differences on the mixing side. Whereas with the unfermented flour, we didn't see really we didn't see much more water being added. With the fermented Okara flour, we saw an increase from the control to the 5% of about 5% more water being able to be added. And then at the 15%, we saw just under 9% more water being added. So anytime bakers can add more water to their process, they're usually happy, because more water means more dough, and more dough means more bread for them to sell. So that is an advantage. On the mixing side, before with the unfermented Okara, the 10 and the 15%, really there was not a whole lot of strength or extensibility in the doughs. I did notice a little bit of that, but not to the same extent at the 10 and the 15% with the fermented. So much easier to handle. On the proofing side, we had no problems with proofing and getting the breads to height. They all proofed in roughly the same amount of time, plus or minus 10 or 15 minutes. So the proofing side worked out much better than the unfermented Okara flour. For looking at the bread quality characteristics, you can see here in the picture, we looked at loaf volume again, and we actually saw an increase in loaf volume at the 5% level when compared to control. At the 10 and 15%, 10% was slightly lower than the control, and at 15, we did see a reduction in the loaf volume. On the texture side, in the crumb, we saw at the 5 and 10%, we saw a pretty significant reduction in crumb firmness. So the firmness of the crumb was much softer than the control. That benefit disappeared, or we didn't see as big of a benefit there at the 15%. So at 5 and 10%, you really saw a softer crumb. Because of this, potentially, and in future research, we don't know why the fermented Okara showed kind of almost a bread improver, but it's possible that a fermented Okara flour could be used potentially as a clean label bread improver. We need to study more about the mechanism of why that's happening, and but at levels no more than 5% would be my recommendation. Next. So we did do a very basic sensory panel just with NCI employees. It wasn't a blind study or anything. They knew what they were tasting, and we just wanted them to give us their comments on texture, on flavor. So this is going back to the unfermented Okara flour, and you can see in the control they thought it was dry, firm, had a good bite, and sweet and nutty. Pretty standard for a whole wheat bread. At 5% Okara flour, you saw that it had a firm texture, maybe larger crumb cells, but some people thought an improved texture, the flavor and aroma, maybe a slight notice of change, maybe a little stringent, but still had sweetness. And then in the 10 and the 15% is when some of those off flavors came out. And if you remember, these are the 10 and the 15% are the breads that did not proof to height. So they were much more dense, much harder to chew through, much firmer, and also had some pretty major off flavors. Next. And then with the fermented Okara flour, at the 5 and 10%, those we saw lower texture values, so softer crumb. The people tasting the bread noticed that as well. In the 5%, 5 and 10%, they noticed that it was much fluffier than the control. Flavors, there were some off flavors noticed at 5%. Some bitterness came through, maybe sour flavors, which you would maybe expect with adding a fermented product. At 10 and 15%, you really notice some stronger off flavors being present. Bitterness came through, losing sweetness, and at 15%, the texture was just kind of dry and crumbly, no resistance. So not ideal. So that goes back to what I was saying, that 5% is kind of where I would recommend the maximum level, especially in the fermented Okara side. But it does have it would be interesting to study further kind of why and if this would be a good clean label bread improver. So with that, I will pass it on to Brian, and he'll talk about Okara in sourdough.
Thank you, Rachel. And again, my processes are what's classified as a type 1 sourdough process. So just generally speaking, this is a very ancient method of making bread where flour and water is in a process of forming a culture similar to what you could call a SCOBY, is a symbiotic culture of bacteria and yeast. And that is maintained to keep a very active ferment for producing bread and bakery goods for a host of quality and taste profiles, as well as nutritional outcomes. So our processes typically are significantly longer than modern traditional bread processes. And so it is not uncommon to see just a standard loaf of bread through a type 1 sourdough process will take at least 5 to 6 hours. So when we were given product from Mint Tofu as a fermented flour, we use the same inclusion rates that Rachel did at NCI, but as part of our process of utilizing it in exactly how we'd produce a simple French bread, which is kind of the standard of sourdough. So it's a white bread, a white French bread that's just flour, water, and salt, and the culture which ferments it. So there's significant fermentation that goes on even before flour and water or any inclusion rates of the fermented Okara flour are added. So what you would see in our processes is what you see as a 5% loaf in this picture, 5% inclusion rate, is almost identical to a standard French loaf that we would have. I didn't have the opportunity to include a control there. I should have, but you would find that they're almost identical. Of course, when you go to a 10% and a 15% inclusion rate, there's significant differences. A lot of that is due to the fact that the sourdough process, type 1 sourdough process, is a much slower process. More active fermentation is going on. Severe degradation of what's being included into the flour is possible. So what's also potentially happening is that the gluten structure is severely impacted by the inclusion rates from 5 to 10 to 15%, which you can see is quite significant. So what ends up happening in the fermentation process in sourdough, due to the slower but yet active fermentation, we noticed a slight increase in the fermentation rate, as well as what Rachel found. As you increase the inclusion rate, the dough changes pretty significantly, and the strength of the dough starts breaking down, and that's noticeable in the mixing processes. We also utilize some unique mixing processes where our dough is mixed and then goes through an autolyzing period for about 30 minutes, and then a secondary knead occurs. So as you get into the 10 and 15% inclusion rates, you can see in the mixer that dough characteristic is pretty dramatically impacted. So One of the interesting things that comes from this process with the Okara flour is a pretty dramatic darkening of the bread, almost as though something like molasses has been added to the bread. So there's a noticeable difference in color, and as well, odors begin to develop through the fermentation process. Typically with type 1 sourdough, you'll get kind of a clean lactic acid profile, a sweet kind of sour flavor that's clean and kind of refreshing. With the Okara flour, there's some different acids and related odors that start emerging that were unique. I don't know how to classify that, but they were much more of almost a soy sauce umami type of smell that was beginning to come through. When you do bake this bread after it's gone through its sourdough processes, there's some noticeable differences. Compared to a control, a type 1 sourdough, a French bread, you'll get usually pretty decent pore spaces, very flexible bread, very soft. With a 5%, we found something similar to what Rachel found. There was actually a slight increase in the flexibility of the finished product, probably due to a little bit of enhanced moisture retention. It does have some nice qualities and characteristics at the 5% level, which apart from some flavor profiles that emerge, it does have some unique characteristics at a low inclusion rate for bread quality. But at the 10 and 15%, there's a noticeable difference, as you can see in the picture, which relates to the structure of the crumb, how fine it is, how dense and gummy it becomes. So at 10 and 15%, it's not something that I would clearly recommend for a loaf of bread. The flavor profiles change dramatically from 5 to 10 to 15%, similar to what Northern Crops found in their studies. At 5%, there's a slight sweet flavor, but a very rapid sour profile that develops right away, and that does linger on the palate. And as you go from 10 to 15%, flavors really begin to change dramatically. At 10%, it's somewhat off-putting, but much of a umami flavor, a soy sauce type of flavor does emerge. So for a bread product, you start developing very savory flavor profiles. And at 15%, it becomes very noticeable. We don't develop what would be a fishy flavor, but we do develop a very strong soy sauce type of umami flavor. So those are somewhat of the overreaching types of quality outcomes from Okara flour. I would concur with Rachel that at 5% there could be some benefits to this. I'm more interested, I would say, as a baker, because we have a broad range of products that we're developing, that it would be interesting to actually place Okara flour within flatbread products. And that would be very interesting to test, because you could be utilizing at maybe a 5 or 10% inclusion rate products for tortillas, pitas or naans that are typically utilized anyhow in savory products. So wraps for meat and vegetables, those types of things, I could definitely see where it may actually be a complementary flavor. But as a bread or cookie product, I probably would not utilize it myself unless at a 5% level, I would see something significant. But by and large, that was our outcome from what we utilized, just utilizing it as we would in our standard bakery processes. So we didn't go outside of what we normally do, other than simply by including it at 5, 10, and 15% inclusion rates. Other than that, that's pretty much where we came down from it. And I'd like to turn it back over to Jason Robinson, and he can follow up with some evaluations.
Thanks, Brian. Appreciate that. The final portion of our talk today is really going to be focused on identifying opportunities for Okara in terms of non-human food applications as a way to monetize this stream for a small Minnesota business like Min Tofu, really in an effort to reduce food waste. So let's start there. To contextualize the scope of the food waste issue in the United States, the USDA estimates that roughly 30 to 40% of all food in the United States goes to waste. If you break this down further, ReFed, a national nonprofit that's focused on ending food loss and waste across the United States in the food system, estimates that roughly 28% of the 997,000 tons of food waste generated in Minnesota is attributed to manufacturing. And this is exactly where the food waste, the Okara stream at Min Tofu sits today. So as we ponder how to impact this food waste problem, the US EPA, the Environmental Protection Agency, developed a food recovery hierarchy, which prioritizes actions that organizations can take to impact the food waste problem. Each tier of this hierarchy focuses on different management strategies for dealing with wasted food. At the top of the hierarchy are strategies that have the most preferred or highest impacts against food waste and climate change. And the value decreases as you go down that hierarchy. So for instance, it's more beneficial to the environment in order to reduce the total amount of food waste than it is to repurpose that food waste for composting, for instance. That said, each organization must truly evaluate their specific situation in the context of the impact according to the hierarchy, coupled with economic analysis of dealing with their food waste at their particular business stage. In the case of Min Tofu, which again is a small Minnesota business that generates approximately a ton of fresh Okara every week, investment in a food recovery strategy cannot produce a net negative result because it may sink the business proposition. So as a result, a URI evaluated a number of options further down that hierarchy, in addition to the food uses that we've already talked about. So let's go through these scenarios in a little bit of detail. And we'll start with the concept of source reduction. As we talked about earlier, Okara has approximately an 80% water content when wet. We speculated that Min Tofu could improve the efficiency of their process by removing that water from 80% and trying to get the moisture down to 70%. In essence, what this would do is this would improve the output from their process to make more tofu from the same amount of beans. At the same time, this reduces the total weight of Okara, of wet Okara that's produced by the process, thus resulting in a source reduction. AURI conducted a study at our Waseca, Minnesota facility using a dewatering screw press to understand if we could force more water out of the Okara using an hydraulic squeezing technique with a dewatering screw press. What we found is that the texture of fresh Okara, which is similar to mashed potatoes, is not conducive to operation and to processing by a dewatering screw press. Thus, that leaves us in a situation where the best case scenario for reducing the moisture content is actually thermal in nature, so drying, as opposed to any sort of physical dewatering approach, which eliminates the opportunity to truly remove to apply the source reduction technique. The second approach we took, again, we've already talked a little bit about human food and how leavened baked goods, or bread in this case, aren't particularly conducive to using high amounts of Okara, which could significantly impact the food waste issue. So while this approach was largely unsuccessful, other applications have also been demonstrated, including the use of Okara as a fiber supplement to baking mixes, which is demonstrated by a company out in California called Renewal Mill, who produces a mix for brownies and cookies today that you can purchase online. Additionally, NCI completed some additional work prior to this study that demonstrated the application of fermented okara as a meat analog in both mixing with fresh meat to extend the value, or as a complete analog altogether and replacing it. Typically, in the industry, we would use this as what's called a texturized vegetable protein. And using okara as a substrate for that texturized vegetable protein did prove successful in combining with and in replacement of meat. And finally, I'd also like to highlight tempeh. Tempeh we've discussed, and tempeh at its core is a cake of fermented soybeans. Typically, tempeh is made with the culture, rhizopus, as Minwei has already talked about, sprinkled over wet soybeans that grow together and form a cake. What we could see is that tempeh, as applied to okara, could also be quite successful in its fermentation and could be used to create a more uniform product. From a messaging point of view, from a value proposition point of view, this makes perfect sense for a tofu company because it's a soy-forward product that could easily fit under the existing brand as a consumer product. So we think there's potential for a tempeh product directly at a tofu producing facility. Next, we also looked at animal food. And as you may know, AURI has a significant positive reputation in identifying animal feed uses from co-product or byproduct streams. In the case of Okara, AURI senior co-product scientist Alan Deering calculated the feed value of Okara on both a wet and dried basis relative to other commodity feed options such as corn, soybean meal, or alfalfa hay. The primary conclusion from this exercise is that while feed value can be extracted from Okara, the freight cost to ship wet Okara at about $8 per ton as an estimate, and the drying costs, which eats primarily into the value of dried Okara, those costs significantly reduce the overall feed value to the point where you can't really extract significant value from Okara as a feed source anymore. And in fact, may actually be a negative opportunity relative to using other commodity products in order to feed your animals effectively. The only case where I would identify Okara as a potential feed opportunity is really if there's a feedlot located right next to the manufacturing facility, such that the wet Okara could easily be transported directly to a feedlot for either further processing or directly to the animals. The final two scenarios we evaluated as we moved down the food recovery hierarchy were waste to energy, and particularly using a technique known as anaerobic digestion. Anaerobic digestion is a process whereby Okara as an organic matter input is fermented in a bioreactor in the absence of oxygen. These reactors contain very complex microbial communities that break down or digest the organic material, particularly the starches in those organic materials, into biogas, typically methane, and to a coproduct solid stream. Now, this biogas can actually be used in a way similar to how natural gas is used for electricity generation, heating, vehicles, etc. So we did find that as it relates to Okara as an input for anaerobic digestion, there is the limited literature and AURI both agree that AURI, and particularly its starch content, could act as a rocket fuel for anaerobic digestion to really kick off fermentation with the right bacterial community. But the primary need here is, again, it requires more research to make sure that we can identify the right microbial community and make sure that an anaerobic digester approach is in close proximity to the producing location, because again, you have to think about the freight cost and all that water that you would be shipping as a result of shipping 80% moisture Okara. And finally, as we move further down the recovery hierarchy into the lowest value opportunity before we get to landfill, we can talk about compost and fertilizer usage. So in the case of compost, Literature suggests that an Okara compost is actually quite suitable for supplying carbon and increasing the humus content of soils, though it does create challenges due to this mashed potato-like texture. In essence, what it does, because it compacts so easily and is such high moisture, it requires significant management of that compost pile to effectively get the right mix of oxygen getting into that compost pile to ensure that the microbes can do their work. Additionally, we did talk to a local business focused on creating soil products, and they indicated that while they would be interested in trying out Okara as a compost, they were unwilling to pay for the freight cost associated with shipping all that water in fresh Okara. So this continues to be a theme throughout these analyses. As a compost then, Okara really receives sort of a tentative green check mark, with the most value coming from what we would say is in very close proximity or an on-site compost facility or even a compost pile. Fertilizer is a bit of a different story. Our analysis indicates that the fertilizer value of an Okara fertilizer, which would have an NPK value of 312, and for those of you that know, NPK stands for the nitrogen, nitrogen, phosphorus, and potassium content of the fertilizer itself, which is critical for soil amendment, is relatively low compared to other fertilizer opportunities. However, the drying of Okara represents a significant investment. So this NPK ratio of 312 is for dried Okara. In fact, the drying actually exceeds the fertilizer value, thus indicating that dried Okara as a fertilizer actually would cost the producer money as opposed to a potential monetization opportunity. So our assessment is that fertilizer value for Okara is really only in the form of a wet Okara till-in soil amendment that can be applied to post-harvest fields or gardens at the end of the harvest year in the fall. Now I'd like to just move on to a brief summary before we get into Q&A. What we found from this work is that fermentation is really a novel treatment to improve the value of Okara, but it's challenging. This study really demonstrated an improvement in the nutritional profile of Okara, including an increase in the amounts of vitamin B12, isoflavones, and increased antioxidant activity. But it's imperative to reduce the moisture content and to limit the competition from spoilage microorganisms through some sort of dewatering and drying approach. We were also able to see that there is potential in packaged human food, but it's limited by moisture, sensory application, and functional impact. This has been demonstrated by companies such as Renewal Mill in the past. And remember, we did identify that you might be able to use up to 5% replacement of wheat flour with Okara flour in leavened products. But at such a low level, the impact of Okara as a nutritional supplement is relatively low. So it may not pay to impact the sensory profile of the product, as we saw in the work that Brian and Rachel presented. And finally, in non-human food applications, we did find that they tend to be limited by the moisture content of fresh Okara. But opportunities exist in the case of waste to energy and compost, which really tended to be the most promising applications. In summary, all of these non-food applications would really be improved in value if a cost-effective drying approach could be defined. And I'd like to end by just offering up an opportunity for anyone who has ideas. Please post them in the chat for other alternative uses, because this is an area of research that continues to this day, as Okara tends to be an under-leveraged byproduct stream with opportunity given its nutrient profile, but is quite difficult in terms of the texture and high moisture content in order to prove a viable co-product stream for significant value add. So with that, I'll turn it back to Dan for any questions that we might be able to answer as a panel. Thanks, Dan.
All right, Jason, thank you. And thank you, panel. Lots of questions have come in here in the last half hour. So we'll try to work through as many as we can here this afternoon. For Minwei, I think we'll start with you. You talked about your fermentation of the Okara. How did you determine the fermentation endpoint?
Thank you, Don. Okay, the microbe is growing. The rhizobes actually, the color turns from white, yellow, and black. So what we will do is prevent the color become black. If it's yellow, it's fine. It means a little bit over mature. So we will stop when it's turned a little bit yellow. Yeah, so that's how we determine it.
Most tofu is made from food grade soy that has been selected for flavor traits. Was this study on food grade or commodity soy?
That's I think it's for the food grade because the tofu is from, mini tofu. So okra is from mini tofu. Yep.
And Rachel, maybe this one's for you since you got us started with or Brian. What is the hydration of the Okara? Did that affect your recipe or your proof?
I guess I didn't look at just the absorption of just the Okara, but Okara mixed in with the whole wheat flour. So our whole wheat flour had an absorption right around like 76% vrinograph absorption. And the unfermented Okara, we saw about a 3% increase on that. The fermented Okara, we saw absorption increases at, it was, 5% at 5% fermented Okara, and then at the 15%, we saw an increase of absorption of about just under 9%.
Do we know the approximate volume of Okara that's produced in Minnesota?
I can take this one. What we can say is that we're only aware of one tofu manufacturer in Minnesota, which is a small business. And that means that they produce roughly about a ton of Okara a week. So they're really looking at about 52 tons a year. So not a huge volume, but Min Tofu as a business is experiencing significant expansion opportunity. And so there might be significantly more produced as time goes on, which frankly would make some of the analyses that we conducted here more cost effective than at the small scale with which Min Tofu is able to produce Okara today. I'm thinking in particular, one of the key challenges is storage of wet Okara such that it allows for spoilage microorganisms to grow. And if there was enough Okara produced on a daily basis to transport it to wherever its end use destination might be, the impact of that spoilage microorganism growth would be significantly reduced.
Is Okara flour, could it be possibly tested with other breads and flours? For example, rye, they mentioned oat, they mentioned pumpernickel. Any thoughts on maybe testing it compared to other flours?
Brian or Rachel, do you want to comment?
Yeah, I could just comment on that real quick. The savory profile in the product would, in my opinion, lend itself more towards a flatbread product. As a bread product, most people aren't looking for savory profiles, although rye bread tends to have a unique profile, or pumpernickel. But you could certainly experiment with it, but I don't know that it'd be a complementary flavor for the bread market. Certainly, I think there's, like I said, some potential for flatbread products like tortillas or pitas or naans.
Since unfermented Okara is already a certified upcycled ingredient and used in upcycled food products in retail, do we have any idea on how much more financially it would cost to get fermented Okara as a safe food ingredient?
I can take that one, Minwei, if you don't mind. Fermentation of Okara, as Minwei had already presented, is certainly a challenge from a capital intensity point of view. And one of the items that Minwei has certainly talked about was the need to reduce the moisture content for efficient and effective fermentation. So while we didn't do any sort of improved or in-depth analysis in terms of the cost, we do know that there is a relatively significant capital cost associated with fermentation, which includes not just incubation chambers to effectively incubate Okara while it's fermenting, but also drying capabilities in order to reduce the content of water down to a point where it becomes a more efficient process. Minwei, anything you'd add to that?
Well, yeah, thank you. So I would like to say currently we didn't do anything. We just take the wet okra and transport it to our facility and then ferment it. So actually, it's actually free, yeah, to be honest. And when they mention about the unfermented, the unfermented okra is already the upcycled food ingredients. They must have the process for the drying and the grinding these processes. But for ours, we didn't do too much before our fermentation. So I think our cost is quite low. Just mix them with the risottos and put them in the oven for a couple of days. And in the future, when we improve it, yeah, maybe we will try to add some costs on it. Yep. So not too much, I think. Thank you.
Somebody was wondering why we don't test the flour at 4%, 6%, 7% rather than just at that 5% level.
Well, I could take that real quick because the answer is just we didn't have that much time. You can test at any number of levels, but we frankly chose relatively easy to understand windows of testing attributes in order to make sure that what we saw was a distinct enough difference between variables so that we could see what the trends were. As you get tighter and tighter into the differences between variables, the differences you might see between variables tend to wash over themselves, and you can't get the distinctiveness of what you see as those windows between variables increase. So that's why we chose 5, 10, and 15%, particularly knowing that the lack of gluten in Okara was going to impact our bread significantly.
Is this the kind of baking research that's being done throughout the flour ecosystem or the ecosystem of grains, beans, and flours? Is what you did being done throughout the flour system?
I think it's an interesting question. I'm not certainly aware of any specific effort to go after this type of research regularly, but I'll tell you, any baker, and Brian, maybe you can add to this, but any baker would certainly be interested in novel additives to bread to really modify the value proposition and to help it stick out from other products in the quote unquote flour ecosystem, if you will, and baking industry.
Yeah, absolutely. I'd concur with that because sourdough processes lend themselves to clean labels and food that's made without preservatives. So anything that we can do that keeps that as it is, but might enhance protein, might enhance other characteristics, we're always looking toward that, especially if it can create complementary flavor profiles.
Any of these findings been published yet? Somebody's asking.
They have not been published yet. We're currently working on that right now.
Do we know how the top tofu producing countries like China and Japan are using their Okara?
So I think I have some words to say about it. So I'm from China, and actually in the harder time, we consume the okra a lot. But nowadays, because of the bad taste and the texture, so only the people want to lose their weight, they would try to consume it. And how we consume it, we just fry the okra with our deep frying, and or make them into the fried bread, and then take it. So not too much commercial available products yet. Thank you.
Does the size of the loaf alter the optimal proportion of Okara flour that's added? Rachel,
no.
you kind of talked about total weight.
Right. Yeah. So we put the same amount with each level of Okara and fermented Okara. We put the same weight of dough in the pan. proof to height so that they all go into the oven at the same size. And so the resulting loaf volumes that you see is what happens in the oven. Some have the strength to spring up in the oven, and some kind of lack that strength, and they shrink down. And that's where you see the variability in the loaf volumes.
And I think Brian touched on this one, but can it be used on flatbreads?
Yeah, I believe that's probably something to pursue. The flatbread market is going to continue to grow as emphasis on blue zone Mediterranean type diets grows, and products with clean labels grows. I think there's potentially some opportunity to look at there.
Question here, have soy and Okara been tested as ingredients in plant-based dog foods and other pet foods?
Yeah, I can answer that. Without being 100% certain, I'm sure they have been. But what I can say is that you run into the same problem that we do for all the other non-human food issues that we explored, which is the need to dry down the wet Okara from that 80% range to a stable range of about 10%, which significantly reduces the value and requires a significant investment in capital to dry it down effectively, largely because of the texture, this mashed potato texture of the Okara, where typical drying techniques aren't quite as efficient and effective.
What technology could be adapted from gluten-free breads to incorporate Okara into the bread system?
I'll take that one again too, real quick. Gluten-free breads suffer really the same problem that we're talking about here, which is a lack of glutinous structure to support the growth of the loaf to get to the volume that you're looking for. So I think you're 100% right. There are definitely techniques in gluten-free baking that work to establish that gluten structure, that protein structure, that allows the baked goods, the gluten-free baked goods, to look similar in height and give similar performance. So we certainly could be adapted there, but I think the goal of this work was really to understand at the base level, could we do a simple swap with Okara and wheat flour and get positive results? Because at the end of the day, what we're using is a waste product. And if we needed to incorporate Okara as a waste product, and the only way to do that is by adding additional ingredients, then the cost of that bread product goes right back up. And that's something that certainly would need to be considered in the past.
I have in the past greatly enjoyed Okara mixed with mashed potatoes and other mashed vegetables and tomato sauces. If using Okara waste is an economic, ecological, and ethical reality, can contests be set up with prizes to attract experienced cooks who could become innovative? Let me use that word instead. Could it become an ingredient in plant-based meats of some kind? And how would Impossible Foods or Beyond Foods look at this ingredient?
Well, I'll repeat the same thing that I said previously. The issue really comes down again to the high moisture content of Okara itself. Impossible Foods, Beyond Foods, they're going to look at Okara in the same way that we discussed today, which is the fact that we somehow have to get it from 80% moisture to 10% moisture for use as a stable food ingredient. Whether it's fermented or unfermented, that drying step creates a real bottleneck in the system that needs to be overcome and overcome efficiently and cost effectively to transform it into a high volume food ingredient. Not to say it's not possible, just to say that it's a hurdle that needs to be overcome, because Okara does create a significant bottleneck in use of that waste, and identifying opportunities to use wet Okara are probably the most cost-effective approach, because remember, we do have to consider economics when we're considering solving this food waste problem as well.
We may be setting a record for questions, but we'll keep forging on here. Will their work be done on tempeh?
We are not planning additional work right now, but it certainly can be and probably should be. I know, Minwei, you've done some work with Okara as tempeh. Not sure if tempeh was your finished expectation, but if you've got any thoughts there.
Yep. So thank you for the question. I think, yep, we can do. Actually, we have did some pre-test for make the okra into tempeh. but the taste, a little bit granny. Otherwise, it's fine because the microbes, the rhizopus can grow well on the okra rather than the soybean. So anyway, it works, and we just need to optimize some processes, some parameters. Yep.
Could robotics be used to manage the compost piles of Okara waste?
Certainly could. Automation is it's a major component to reducing labor costs. But again, you've got to consider the value of that automation relative to the value of the finished product. Compost, as a general rule, is not a high value product. Thus, investing in automation, unless you're working at an incredibly high volume, might not be a cost-effective strategy. But it certainly can be done. The question is it cost-effective to do so?
Can Okara waste return nutrients to the soil of the farmers where that soy was grown?
It can, as I mentioned when we talked about fertilizer, it could. It definitely could be. The difficulty becomes, again, because of its high moisture content, the actual nitrogen, phosphorus, and potassium levels in Okara are low. When it's dried to, I think the value was, when we considered a bone-dry version of Okara, the NPK ratio was 3:1:2, which is much lower than a commercially available fertilizer, which is typically 10:10:10. Wet Okara is actually significantly lower than that, in the range of, I believe, if I remember right, it was 1 to 0.5 to 0.2, which means that it doesn't provide significant fertilizer value to soil in its wet form, but it doesn't mean it doesn't provide any value. So it could certainly be used as a till-in soil amendment that produces some level of life back to the soil, but it's not a significant amount of life back in the soil. Drying it down to get the maximum fertilizer value, again, presents that issue related to cost of drying, but dried Okara could certainly be combined with other ingredients to add back into the soil for soy farmers.
Here we have more of a statement, but they say wet and unfermented tofu Okara may be better suited for sweetbread and pastries, banana and fruit breads, muffins, because higher sugar content helps counter some of Okara's adverse effects in regular breads. No question there, but a statement.
Yep, great, thank you.
What might happen if the initial total moisture in soybean processing is 75%? Minwei, is that something you've considered? What if we have the soybean processing at 75%?
Well, total moisture in soybean. Does he mean this in Okra? I didn't get the answer well, but okay. So let's say, so I don't know if we tested the 70% moisture in Okra and the 80% moisture in Okra, and so like we said that the 70 works, but the 80% seems a little bit impede the oxygen to go through the layers, so it doesn't work well. So as a soybean, maybe he means the milk. I don't know yet. Thank you.
And then we have a question that says spraying, drying.
Sure. So could spray drying be used to improve the drying capabilities? And I think the answer is probably not, because spray drying requires some liquid form in order to dry down and reduce to the particle size. Okara at 80% moisture, believe it or not, is quite dry to the touch. So spray drying as a tool might be a difficult approach for this type of product, because it's not suspended in moisture at all, in liquid at all. But it certainly could be something to explore as a technique.
And here's a question, and I'm going to hopefully get it pronounced right. Poulamon. What does Poulamon do with its waste?
I am not sure what that is, to be perfectly honest.
Maybe, can you see the question?
I can,
Maybe I'm mispronouncing it terribly or something. I see nobody willing to run to the bat rack and take this one, so we'll move on. We need to develop here's another comment. We need to develop an Irish soda, a soda bread called Okara. Sorry, had to do it to get samples. Anyone producing in bulk for purchase, it says.
We could certainly connect you with, if you're interested, we could certainly connect you with Min Tofu to get some samples, because you might, if you've got some opportunity, maybe there's something there. But in terms of commercial availability, very low, because people just want to get rid of it as fast as possible.
I believe we have 4 questions left. Any information on fertilizer use? Okara is an excellent fertilizer for small scale, high value horticultural crops like fruits and vegetables and flowers.
Yeah, we did discuss the fertilizer value for Okara already. Just very quickly in summary, what we found is the best use of Okara as a fertilizer is in its dried form, which requires, again, investment in drying to get it down to the somewhat reasonable NPK ratio of 3:1:2. In its wet form, the NPK ratio is significantly lower, such that it doesn't provide a whole lot of nitrogen, phosphorus, or potassium back to the soil, which is typically how we measure fertilizer value. So in that case, we believe that the best case scenario for wet Okara is actually as an end of season till-in fertilizer that can be used as a soil amendment for the next season's, the next growing season.
Can the fermentation process be modified to reach different outcomes with the Okara flour or other fermentable grains or legumes? TVP is produced under varying heat, pressure, and time length processes. How about modifying fermentation?
Well, yeah, so I can take this question. So fermentation is a widely applied techniques for all kinds of like agriculture crops or products. So yes, and we just tried one variety, like the rhizopus, to change the okra, and it can also be applied to other crops. And I think it's well known, like maybe many condiments like soy sauce and some sauce, other kind of sauce, and wine. They are made from the fermentation processes. So yeah, it's definitely possible. And we are trying to, in the future, well, to try to figure out if other like microbes, not only rhizopus, or like Aspergillus oryzae or some other yeast can work on the okra, and so that we can make more use of the okra. So yeah, it's depending on grants maybe. So yeah, thank you.
And we'll leave you with each answering this question. Have any of these culinary adventures been shared with members of your family? Rachel?
No, unfortunately, I didn't. Everything stayed at work.
And Brian?
My family is currently my guinea pigs for everything. So I think they would also concur. I think they'd be interested in trying some tortillas or pitas or naans on that in the future.
Minwei?
Yeah, I think, yeah, we didn't do it yet. Yeah, so in the future, maybe we will try. Thank you.
How about you, Jason?
Well, my wife is also a food scientist. So she is open to being a guinea pig for other food products. But in this case, I did not share them with her. And my kids have learned to be wary of anything Dad says to try. So so they usually tend to avoid.
Well, with that also concludes AURI Connect's Webinar Wednesday for today. We do want to thank our presenters and our panelists today. AURI Connect's Webinar Wednesday is presented by the Agricultural Utilization Research Institute of Minnesota. AURI's mission is to foster long-term economic benefit for Minnesota through value-added agricultural products and processes. We are interested in your feedback, so please respond when we send you our event evaluations. Remember, for more information on today's program or any of the work that AURI is involved in, you can go to auri.org. Next month, September 8th, please join the Agricultural Utilization Research Institute and Clutch Business Acceleration experts in learning about a new online resource funded in part by the Minnesota Department of Agriculture, delivering fundamental information and considerations for food business as they consider how to build their brand's online presence. This webinar will highlight content from a new online AURI resource on demystifying digital marketing and e-commerce for food businesses and a related entrepreneurial experience. You can always learn more about other work AURI is involved with by going online to auri.org. Looking forward to having you join us again for another AURI Connects Webinar Wednesday.